In the scheme of things, Joe's ride down was gentle. For out in space, gravity can get really extreme. Albert Einstein once imagined a class of objects with such intense gravity that nothing, not even light, escaped their grasp. He called them dark stars, but he emphasized that nature could never be as strange as his theory. As it turned out, his nightmarish imaginings were exactly right. There is a kind of star that grows so heavy that it collapses inward, then blows up. The mass of many suns is sucked down to a tiny point. A terrible dark vortex. A black hole.
Black holes are where gravity's gone bad.
There aren't just one or two black holes out there. In our galaxy alone, there may well be millions. Many exist in the dense hothouse of the galaxy center. In this image from the Chandra X-ray telescope, each point of light is a collapsed star that is lighting up as it devours a companion star. But there is another object here that is far more potent. Not just a black hole, a monstrous, supermassive black hole. Scientists are urgently trying to find out more about it. For over a decade, a team led by UCLA's Eric Becklin has been searching for it, deep in the center of the galaxy.
I believe that we don't know everything by a lot. Never would have predicted that there is a black hole in the galactic center, that the stars are moving around it at speeds of 1% the speed of light. I just would never have thought that that was going to be the case.
It's not easy to find this monster, much less study it. The astronomers can only glimpse it by tracking nearby stars. These stars are circling the supermassive black hole, whipping around it at enormous speeds.
The acceleration tells you where the black hole is. So each star says the black hole is there, and the next star says the black hole is there. So if you can find the intersection, you've actually precisely located where the black hole is.
The basic tool of their hunt is the Keck telescope, the largest in the world, unrivaled in its power to magnify light signals from the most distant points in the universe. The team begins by aligning Keck's immense 30-foot mirror to ensure a near-perfect image. Then they fix on a bright star near the galactic center, a guide star, that will allow them to lock onto their target.
We're looking at a patch on the sky that corresponds to a rock on the moon. So if you think about the moon on the night sky, the moon extends, you put your thumb out, that's about the size of the moon, at arm's length. And we're looking at a part of the moon that corresponds to the size of a rock.
Using the Keck telescope, they're peering into a pinhole at a region not much larger than our solar system, filled with stars.
For us, they're just signposts to where the center is, and what we're really interested in is in watching the motion of these stars around the massive object or black hole that we now know is right here in the galactic center.
According to the team's data, this black hole is 3 million times the weight of the sun, compressed down to a size smaller than a speck of dust. It's among the largest and most powerful objects in the universe.
With the supermassive black hole in the center of the Milky Way galaxy, and in most galaxies that we've observed, you can think of them as a hungry dragon. It's sitting there with its mouth open. Now, it doesn't reach out and grab you, but if you happen to fly a little too close, it's got you.
The astronomers are hunting this dragon, seeking clues to its turbulent past. It may have begun as a smaller black hole that gobbled its neighbors, reaching an enormous size. Or it could have formed earlier, as gigantic gas clouds crash together to form the galaxy? We may never know. For deep within the bulge, the shearing action of gravity has erased all traces of the past. Here lies the giant black hole. It sits at the very center of the galaxy, amid clouds of dust and gas bursting with star formation, dense star clusters, and great rivers of gas flowing directly into its mouth. As massive as this black hole is, it will grow larger on a steady diet of stars and gas. Eventually, it will become so large that it will transform the galaxy itself.